So from the previous video, we had one problem left to do. We're going to do that in this video. Here is the slide that had all of the formulas on it. And we're going to have these handy with us actually as we solve this one, particularly these 5 formulas here. Now, inside the classroom, these formulas are actually posted at the front of the classroom right at the top near the ceiling. So you might want to take a look there, find them. That way you have easy access to them whenever you need them. Okay, so let's tackle that problem. So a ball was shot straight up into the air with an unknown velocity next to a building. Mr. Tang is standing by a window that is 2.0 meters tall and whose bottom edge is 6 meters higher than where the ball was shot from. If the ball took 0.50 seconds to travel the entire length of the window, then with what velocity was the ball initially fired? I am going to draw a picture of what's going on here. So we have some kind of a building, probably an apartment building. And there's a ball that gets shot up. That is not a straight line. Let's try that again. Okay, the ball gets shot straight up. Now I am looking out a window that begins 6 meters high. So I'm going to create a window here. Okay, so there's going to be my window. And this can be my apartment. Okay, so that's the window. It's a 2-meter tall window. And it began 6 meters high. Now, the ball takes 0.50 seconds to travel the length of the window. So that's only this 2-meter part. There was a time elapsed of 0.50 seconds. Okay, so that's the situation. And I need to figure out the initial velocity. So the ball at the bottom here, how fast was this ball shot at? I'm going to label that as V1, harpoon, initial velocity, and it's a question mark. That's what I have to try to find out. Now, to find that out, there's different ways this can be done, but the way I'm going to show is to split this situation into 2 parts. I'm going to say the first 6 meters here, I'm going to call that part A of the problem. And then the window part, the next 2 meters, I'm going to call that part B. And I'm going to organize my information here under 2 headings, A and B. That actually is a really important skill to be able to do in physics, is organize the information. All these numbers, what is going on, your mind's all mixed up, so we got to get some organization done. So in part A, what is known? The displacement is known. It is 6 meters up. And that's about it, at least in the wording of the question. Now, something you need to know is the acceleration in these situations, because it's due to gravity. And gravity is going to cause this ball to slow down, actually. And eventually it'll pull it all the way back down. But at the beginning, it just causes the ball to slow down at an acceleration of negative 9.8 meters per second squared up. Now I chose to write negative 9.8 up instead of positive 9.8 down, because I want not just my units, but my directions to be matching in all of the variables I list out. So listing out, since I already listed out an up direction for displacement, I want to match that direction when I list out my acceleration. So I chose to write negative and up for gravity. Okay, what I do not know is the starting velocity. That's what I need to find out. And if I try to use one of the equations on the previous slide to find it out, you'll find you don't have enough information. You actually, with those equations, you actually need to know 3 numbers if you're going to want to calculate a new number. So right now I only know 2 numbers. I don't have enough to calculate that new number. So what can I do? It seems like I'm stuck. Well, I am stuck. So I'm just going to leave that there for now. And I'm going to work on part B and see if that will give me any insight. Okay, so sometimes you start a solution and you get stuck, and you might not have to erase it all. You can just find a different part of the page and start working on a different part of the problem and see if there's a connection between 2 different parts of the problem. And there is a connection between parts A and B. And I'm going to try to point it out on the diagram. In yellow here, right at this moment, that's the transition point from part A to part B. What's the connection? Well, the ending velocity of part A is going to be equal to the starting velocity of part B. Okay, we're assuming it's just a continuous situation here. So whatever velocity it had at the end of part A, that's going to be the velocity it starts with at part B. And that's actually a connection between the 2 parts. So if I can somehow find that out in part B, I can transfer that information to part A. And that might help me to go back and solve part A. The ending velocity of A is equal to the starting velocity of B. So I'm going to go to part B here. I'm going to list out my givens. I know the displacement in part B is 2 meters up. And the acceleration is still due to gravity. Again, I'm going to write it as negative 9.8 meters per second squared up. And here I also know the time, so that's nice. I have a third number here. The time in part B is 0.50 seconds. So with these 3 numbers, I can figure out the other kinematical quantities. And the one I want is the starting velocity. Okay, I want the starting velocity. So I'm going to find the formula that relates these variables. You can look at the front of the classroom at the top there and try to find which of the 5 formulas relates these 4 variables. And you should identify it as the 3rd formula, which I will write down now. Okay, that is the formula. Now we're going to want to isolate for our unknown, which is V1. So you have to apply your algebra skills here. So my first step is going to be to subtract half a t squared. That whole term, that whole chunk after that plus sign, I'm going to cancel it out by using subtraction. The opposite of addition is subtraction. I'm going to subtract it on both sides. So the next line will look as follows. Delta D minus half a times squared will equal V1 delta T. Okay, that's my first step, and I'm actually really far along now in isolating for v1. My goal is to get v1 all by itself. The only thing left to do is to cancel out the delta t that's being multiplied to it, and we cancel that out by dividing. The reverse of multiplying is dividing. So I'm going to divide both sides by time, and I am going to do that by striking it through, then adding a fraction line here, and then putting the time underneath. So that essentially is dividing both sides by delta t. Okay, so now I am ready to substitute the numbers and solve that. So I will use the space over here. So the displacement is 2 minus half of negative 9.8 times 0.50 squared, all divided by 0.50. Okay, so this I will put into a calculator. Just give me a minute here. Okay, so I got 6.45 when I put that into the calculator. And that is going to be good to 2 significant digits due to the 0.50 that it's being divided by. Okay. There's a chance I typed something in wrong, but we're just going to go with that number. You can correct me if you get something different. All right, so what do we do with that? Well, the 6.45 meters per second, that's how fast the ball is going at the yellow mark in my diagram. That's the starting velocity at B, but it's also the ending velocity at A. So I'm going to take that number and I'm going to transfer it to my list of variables here for part A. I'm going to call it the ending velocity. And now I have 3 numbers listed under part A. So I should be able to calculate a 4th number. And I'm looking to calculate V1. Okay, so we need to find the formula that relates these 4 variables. You can look at the front of the room again and try to find that formula. It is actually the 5th one. So running out of space here, I'm gonna go down here. The 5th formula, I'm gonna just write it out. This needs to be isolated for the starting velocity. You need to isolate it for V1. So the steps are similar. Actually, the first thing I will do is cancel out the plus 2a times d by subtracting. Subtract both sides by 2 times acceleration times displacement. Okay, so that's the first step in isolating. And now I just need to square root both sides to cancel out that squared. So V1 will end up equaling plus or minus the square root of this whole expression here. Now the negative answer is inadmissible. It does not start going down. The ball definitely starts going upwards, so this will be inadmissible. The negative will be inadmissible. Okay, so now I will substitute the values in. need to be careful to include everything. Don't forget the exponent. Don't forget negative signs if there's a negative sign. Okay, so I think I wrote that out accurately, and now I'm going to be typing it into the calculator. And the calculator is giving me two significant digits. It would round to 13. I got 12.6 to two significant digits. It rounds to 13. Okay, so there's an example of a more complex problem. It required organizing the information into two parts and finding a connection between the two parts. How can you solve something for one part that can be used to help you solve something for the other part? All right, so now you guys can practice with the problems that are posted on your Google Classroom.